All right, well, most of you know that the Bureau of Land Management, Western Oregon, just Western Oregon, is going through plan revisions version 2. I've heard it called Whopper 2, Scooby-Doo. They all have their favorite little words of what they're calling it these days. Carolina Hooper is, she's been tasked with being in charge of the vegetation modeling for the new planning effort. And she's going to talk about Woodstock, which is the model that they are going to be using to figure out some of the trade-offs that go into that planning. So help me welcome Carolina, please. While I pull up your presentation here somewhere. Or am I missing it? Oops.
Landscape modeling for RMPs. Yeah, just 2 down. Yeah.
Thank you. It'd bite me if it was anywhere closer. There you go. Okay.
And how do I work this?
Forward, backwards, and the pointer's right there.
Excellent. Okay. All right. Well, I am Carolina Hooper, and I'm a forester with the BLM, and I'm in charge of the vegetation modeling. And unlike some of the presentations that we've just seen, I'm not going to be talking about a project which is finished and done and giving you results. I'm going to be talking about a project which largely is being developed right now and which will be implemented in the next couple of years. So some of what I'm going to say is somewhat, which is our plans for what we're going to do. We'll see how well they work out as time goes on. We signed the notice of intent to do a set of RMPs for all of the west side BLM districts. That also includes the west side that also includes the Klamath Falls resource area and Lakeview. We signed that last spring, but the vegetation modeling has really just gotten started really in December. Like I said, a lot of what I'll be discussing is our plans for the future. Okay, so what is the intent of landscape modeling? And for us, certainly, landscape modeling is to simulate the actions and allocations of the alternatives to project the development of the forest over time. And this is being done for NEPA analysis. I mean, we want to have some clear definition between alternatives for both the public and the decision makers to understand what's being proposed. I'm going to take you through a quick trip down through memory lane because the BLM has actually done, this is the 3rd major planning effort that we've been involved with in the last 20 years. The first one is the Northwest Forest Plan. That is the plan that we still manage under. The modeling that was done for that was primarily what we call allocation driven. We used some very broad assumptions on how forests would develop through time. There's very little vegetation modeling actually done for that, and we used a 40-acre pixel size. We've had 3 plan evaluations. Some of the aspects of the Northwest Forest Plan are working very well, and others we don't seem to be able to implement as well as we'd like. So after the Northwest Forest Plan, we developed our own RMPs. We did some modeling for those RMPs. We used a model called Trim Plus. The harvest scheduling and modeling was really just done on our matrix land, and outside of matrix, on the other allocations, we used basically some age-based habitat interpretations. Next came the Western Oregon plan revisions. These started in 2000. Well, I guess around 2005, and we signed the record of decision in 2008. This was a much more complicated modeling endeavor. We modeled vegetations on all land use allocations. We looked at the rate of change in forest conditions. This was we used spatial projections and analysis. And the model that we used for this was called Options. It's kind of a scenario-based land management simulator that is developed by DR Systems. Much of what we're going to do, so right now we're just about to embark on our third effort, resource management plans for Western Oregon. We wanted to make sure there was no possible acronym that could come out of it. Very similar to the Western Oregon plan revisions. We're also, once again, going to be modeling vegetation on all BLM forested lands. We're looking at the rate of change in forest conditions, also spatial projections, but we're using a different model, one that's called Woodstock. It's a linear program-based forest management model developed by a company called Remsoft. So I'm absolutely thrilled that Alan gave the presentation on linear programming 2 presentations ago, because he introduced the concepts and the vocabulary associated with linear programming, and also some of the concepts that you sort of need to think about the problem in terms of mathematical programming, which is what linear programming is. So a modeling philosophy, well, when you go through a major modeling endeavor, such as the resource management plans, there's a lot of different choices that you make. But really, one of the most fundamental choices that you have is a decision on what data are you going to use. What is your basic data that you're going to be carrying forward into the future? And so I have written up this is our modeling philosophy, and to the extent possible, we use data that's been collected on BLM managed lands. Our stand level and permanent plot level information has been developed, collected, and maintained by BLM employees for use in developing RMPs, and provides us with the best available information. We have 3 main sources of data that go into the model. The first is our forest operations inventory. This is our stand level inventory information. It's been maintained. We have information that goes back I guess it goes back. We have stand age that goes back for hundreds of years, but we certainly have stand level information that we've collected since the 1940s and 50s. Our permanent plot inventory is our current vegetation survey, and of course a lot of information comes into the model through GIS. The FOI, Forest Operations Inventory, we have information on about 80,000 stands. The information's been derived from stand level inventories, of stand exam, photo interpretation, and also LiDAR. The information in there includes information on stand age, treatment history, vegetative description, and condition, surveys that have been done, as well as location. There's actually many attributes in that database. It's called the Microstorms database. This is an example. Of course, the BLM manages, for a large part, a checkerboard ownership. We manage every other section. So this is an example of a section. And each one of the polygons on here would be representative of one stand, and the database would contain all the information I just described on each one of those. So what is the model going to use from the FOI, from our stand level inventory? Well, it uses stand age, and it uses also the description. So the birth date, the forest type, the density of the species in the overstory and the understory, and some very basic types of management history. Like, is it a managed stand? Has it been planted? Does it have a harvest history? Has it been pre-commercial thinned? So the next major data input is the current vegetation survey. This is a permanent plot inventory that the BLM began installing in 1997. We finished installing actually in 2011. So for the first time, we're able to have change information on the measured data elements. This is new. When we did the Western Oregon plan revision, we would just use our Occasion 1 data, so this is sort of a kind of a new, exciting opportunity for the ID team. So permanent plots have been established on a systematic grid across all BLM lands in Western Oregon. If one or more subplots fell on BLM and the plots in a forested location. The last part is just on the measurement dates, 1997, finished in 2011. We have about 1,400 plots, so that's one plot for every 1,600 acres of forested land. The database contains, 210,000 trees. Each tree's been individually followed through time. So we have growth, ingrowth, mortality. We also have for each site, for each condition class on the plot, 1 to 5 site trees for all condition classes that are over 20 years old. We also have a lot of information on dead trees and also down wood. Dead trees, 30,000 dead trees. These have been individually identified. We have height, decay class, species, as well as insect and disease information on hardwoods and softwoods. 34,000 pieces of down wood, anything over 3 feet long, 3 inches in diameter has been tallied. They're not uniquely identified, but we do have, occasion 1, that's our first measurements, as well as as well as our second measurements for hardwoods and softwoods. So what's going to be used from CVS? Well, the CVS plot is divided up into 5 subplots. The measured tree lists on each one of those subplots are what is actually grown out in the Organon model. We'll be using empirical data to describe older stands. We'll also be modeling the snags and downwood data, as well as information that we collected on marble murrelet platforms. This is just a photo showing where just the relationship between the CVS plots, this 1.7 miles, and the stand layer. You can see that each one of those red dots represents a 5.1 hectare circle. There's 5 sampling points in a 1 hectare circle, and each one of those actual sampling points in there is correlated with the stand information. So tree lists from CVS are used to simulate growth in yield and vegetation change in stands. Okay. Finally, the third input to the model is the GIS data, very important. We've spent a lot of the last year updating our GIS layer, because even though you're doing analysis on a no action alternative, it has to contain the information that's current right now. For example, the no action alternative will be containing about, I think, 65 different GIS layers. These are all combined into 10-meter rasters, and those are put into the model as the data elements. It's kind of a study in acronyms, but so this is just an example of some of the GIS layers that are going into the model. Site index, as every forester knows, site index is very important in how your vegetation is going to be changing. So we have measured site index on about 625,000 acres. The measured site index comes from the CVS plots. It also comes from stand exam information, as well as our permanent plot inventory prior to CVS, which is called our continuous forest inventory. So that covers about a quarter of the planning area. For the rest of the planning area, we're using site index coming off of NRCS site index maps. And we're adjusting the NRCS classification to move the acres between site classes so they're roughly proportional to what we found in the CVS distribution. On to the models. So our harvest schedule and the harvest scheduling and changes in vegetation composition and structure, we're going to be modeling with Woodstock. We've contracted with Mason, Bruce, and Gerard, a consulting company in Portland, to set up and run the vegetation model. And the growth and yield modeling, which is a part of that, will be done using Organon. We are also doing a comparison between, since we do have 2 sets of data, one of the questions of interest is, how does our data compare to what we see, simulated in the Organon model? And so we're doing a growth comparison between our first occasion measurements and our second occasion measurements with the Organon model. The BLM is clearly in the realm of strategic level planning. We're looking at, in total, our project area is about 2.5 million acres. We'll be running we need to do a sustained yield analysis and declare ASQ for each one of our BLM districts. To do that, we run our models for at least 200 years. In 2008, we ran them for about 400 years just to make sure that the level can be sustained through time. It's also, we need to do a spatial representation and analysis. Many of the points that were, many of the points of interest are actually, specific locations on the ground, and we need to know how that specific location is going to be affected. So Woodstock is, it can be used, it's most often used as a linear programming model. So like I said, I'm very glad that Alan gave his presentation first. He is an operation research analyst, and I'm not. I'm a forester, so this is not really an area of expertise. I'm learning an awful lot. But a lot of the vocabulary that he's talking is the same sort of vocabulary that we're using in trying to figure out how to set up and build this model. So linear programming models, they look for best solutions among a number of management scenarios. You specify the types of solutions that you're looking for, and then the model solves, basically mathematical program functions, to determine what activity levels are needed to achieve our goals. This is fundamentally different from the way we have done previous efforts. For example, in 2008, with the options model, essentially we used a scenario-based analysis methods where we have a number of allocations. We say this is what the allocation is, this is what we're going to do out there, and then the model spits out an answer, and you think about it for a while, and you say, okay, well, that looks reasonable. Maybe we want to change that a little bit and do something else. But it's really the thinking about whether you change it or not is on your part. You're not really asking the model to come up with a solution for you. So this is actually, I think, really an interesting, this is sort of the point that we're at right now with Woodstock is, putting everything in there and then thinking about what kinds of questions we're going to ask the model. But so much of how we manage our land is actually very constrained. Sort of ideally we would ask the model, well, where is the best place for us to be creating spotted owl habitat, and where's the best place for us to be harvesting, or questions of that nature. But in fact, we, to a large degree, we're told those things already. And so the optimization, we'll have to see how this turns out, but the optimization is probably going to be, more contained than obviously the entire landscape. So what goes into Woodstock? Well, first you need a method of describing the forest. You need a classification scheme. That's what's going on right now. That's what we're doing right now, dividing up our CVS plots into different kinds of bins so that those can be grown out in the model, classified. Also, the second thing is a range of silvicultural activities and natural events. We need to describe each one of these in terms of management regimes. What would happen out here? What would be the end? What would be the end products? How would these areas change through time? You need a means of measuring the impacts of the interventions and the natural events, as well as a method of accounting for the passage of time. So what's new in the RMPs for Western Oregon? Well, this is, as I said, this is somewhat speculative since we haven't quite done this, but at this point, these are things that we are planning to do that we did not do for 2008. One is that we are going to we're going to be incorporating stochastic change due to fire in the model runs. This is primarily because the 15-year monitoring report for the owl came out. The status and trends of owl habitat said one of the main reasons that there's been a loss of suitable habitat is wildfire. And obviously, you think about what's foreseeable in the future, wildfire is very probable to happen. So we did not include this last time. This is something we're going to be doing. We're also planning to model snags and coarse-woody debris, as well as developing habitat suitability indexes for the northern spotted owl and the marble murrelet. We'll be following, in 2011, there's 2 GTRs that came out, kind of describing a process for doing that. You get a rating from 0 to 99 for each one of your polygons for how well one of these birds would do there. We'll be following that process, doing a very similar process. And we'll also be doing demographic modeling for the northern spotted owl, and we will be doing that across the entire range of the owl. So as the capabilities have increased and the complexity of our management has increased, so has the expectations for modeling. Specifically under ESA, we need to understand the interrelationships between how actions on BLM may affect species demographics range wide, and also how actions on other ownerships may affect what we do on BLM. For most species, we don't have the kind of data to do that, but we do with the spotted owl. We'll obviously be benefiting from the work that's been done in designating critical habitat, as well as the 15-year monitoring report. There's a lot to build on. But it's also a big project, and it's not the kind of thing that we've done before. So we're kind of treading on some new ground. Outside of, on BLM, we'll be using our CVS and our FOI to characterize growth in our stands. Off of BLM, we'll be using GNN data to do that. There are some other models we'll be using. The Habitat Suitability Index for the spotted owl and the murrelet. We'll be using the MaxEnt model. To do the demographic analysis, we'll be using the HexSim model developed here in Corvallis at the EPA. Our timeline, so right now we're putting inventory plots into strata. We're about to begin the growth and yield work probably this week. Hoping to do benchmark runs in June and July. That's essentially a run where we're just going to let the model run without doing any harvesting or any optimization for 200 years. Sort of, it's an opportunity for us to see how Woodstock grows the trees, grows and changes the vegetation as compared to our very recent effort in 2008. Another benchmark run will probably be sort of a max harvest run. Not that that's going to actually be an alternative, but it does provide kind of a, bookmarks on either side of what the possibilities could be. Then we're going to move right into the no action alternative. That is the no action alternative as written in the Northwest Forest Plan. And then we'll be developing alternatives this summer, fall, and early winter, and modeling those. We should have a draft DIS by next winter, and final RMPs in the winter of 2015. So I just have some information here on the project manager. There's lots of questions when you do an RMP that don't have to do with veg modeling, and if you have some of those, either Mark or Jody would be happy to help you out with those. I'm the person to talk to in terms of veg modeling, and that's our website. All right.
Questions for Carolina? Far back left.
Yeah, I was curious, unless I'm misunderstanding, so my understanding is GNN includes Forest Service plots and BLM plots, so I'm assuming it already includes some of the plots that you'll be using on BLM land, and you still need to take those plots and somehow make them spatial, to map the vegetation. So do you think your methodology is better than the GNN data, and that's why you're using GNN off BLM and some other process on BLM, or can you explain what's going on there?
Okay, so the question is, if I understood it, is doesn't GNN data already include the CVS plots that we have in our permanent inventory, and so why you need to take those and make them spatial in another arrangement? Okay, all right. GNN is actually based on the FIA inventory, this Forest Inventory and Analysis. They have plots across all land ownerships. They do have plots on BLM. They have about 350 plots on BLM in Western Oregon. So that's a small number compared to the 1,400 plots that we have with the CVS. So it's actually not, it doesn't use the CVS information. And then GNN is, it's an imputed information sort of from this, so it doesn't actually use, the information at any given point is based on the Landsat information, and then it pulls information from FIA to populate that area. So it's less accurate at a specific location. We feel pretty confident that our stand descriptions are basically what is there at that exact point. It's not so much just a map of probabilities of what's in the area. It's what is actually at that point. So is there more to your question?
So there's a disconnect in my mind, and it may just be misunderstanding, but you have to take your plot data and essentially also create a map, a spatial map, so you don't have plots everywhere.
Exactly,
You have
that's,
to
yeah.
extrapolate some like GNN that uses imputation, and I assume you're using some other methodology to do that.
Right, so that's, yeah, so her question was, so how does the CVS, how are we extrapolating our CVS information out to the landscape? And the way we're doing that is, I think I showed one slide where you can see the CVS plots and the stands. So each one of those actual subplots is typed, is sort of matched up with the stand that it's in. And then similar stands are grouped together, and the tree lists that are from that CVS plot are then grown out. So it's a matter of sort of grouping together similar types of stands and then using the subplot information from those stands. Okay? Yeah. Are there any other questions?
Okay, thank you, Caroline. Help me thank her, everybody. All right, a little levity to take us into the end while everybody leaves. I first moved to Oregon almost 30 years ago. I started working for the Eugene BLM. I'd never seen an elk in the forest before, and I came driving around a corner, and there was an elk running down the road in front of me, and I went, oh my God, what is a camel doing out here? And everybody in the car decided my zoology degree should be pulled back, and I should not advance beyond my GS3 grade level.